is it? Okay, here it is. This stuff is going to be like some I stuff.
Okay.
So, so can we go over, I think this one, 8 minus I over 5 plus 7I.
All right. By now, you've probably figured out that adding complex numbers is easy.
Mm-hmm.
Subtracting is easy. And multiplying, you just FOIL it. And
Yeah.
convert all your I squareds to minus 1.
Mm-hmm.
The only one that is even somewhat difficult is division. And that's because it's not really division.
Mm-hmm.
Okay? In other words, what we're going to do is we're going to make the denominator a real number. Similar if I said 1 over square root of 2, you would rationalize that to get square root of 2 over 2, right?
Yeah.
So that's not really a division problem, it's a multiplication problem. And the same with complex numbers. In other words, what we're going to multiply it by in order to make it real is its conjugate.
Which is the opposite, right?
Yeah, it's just the different sign in the middle. Everything else is the same. And
Yeah.
since I can only multiply any fraction by the number 1, if I multiply the bottom by that, I got to multiply the top by that. In other words, that's my number 1.
Okay.
Now, go ahead and do the bottom first.
So it's 25, right? And then negative 35I.
Go ahead.
Negative 35I, sorry, I got the hiccups there for a second, right? Or minus 35I.
Okay. What's the last term?
And then, well, it would cancel out. Would the 35i's cancel out because one would be positive and the other would be negative?
And they always will. That's the whole reason we multiply by the conjugate. Notice that that's the difference of perfect squares factored. So there's never going to be a middle term. All you have to do is square this term, subtract the square of that term.
Okay.
Always.
And that's going to be 7I squared, or 49I squared, I mean. Minus 49I squared.
49I squared.
And then that's, well, 49I squared is negative 1, right? That's
correct.
The equivalent.
And that's the one you always want to look for. In other words, you can't you don't really want to substitute for I. You don't want to substitute necessarily for I cubed. But when you see an I squared, always know that you can substitute negative 1 for that. So what's the denominator become?
The denominator becomes 74.
Okay. Now we still need a numerator.
And
again, let's write it here. FOIL it.
It's 40. Then it would be what is that? 54I, right? Or 56I. And then it would be negative 5I or minus 5I. And then it would be positive 7I squared plus 7I squared.
Okay, now simplify that. You can always combine those two middle terms.
And that'll be 51I. Minus 51I, negative 51.
Actually, it looks to me like minus 61. We got minus 56 minus 5.
Got it, yeah.
That's a minus 61i.
Yep.
Now, what's that equal to?
And then that's equal to -7.
And combine it with the 40.
So that's 33.
So that's
or not 30. Yeah, 33.
Yep.
Yeah.
That's our new top. That's the answer except for one thing. But notice that we do not mind having an imaginary numerator. It's only imaginary denominators. It's kind of like irrational denominators. They want you to get rid of them.
Okay.
Now, there is such a thing as A plus BI format. This is the standard format for a complex number, where A is a real number, B is a real number, but it's the coefficient of I. So sometimes, I don't know whether your class or teacher wants you, is okay with that as a final answer or not. If the instructions say put your answer in A plus BI format, then this becomes 33 over 74 minus
61.
74i.
Okay.
Now, I cannot simplify that, and I don't think I can simplify that. I think 61 is prime. So that's the perfect answer. But like I said, if they don't specifically say put it in A plus BI format, then you can probably get away with that answer above it.
Okay.
Okay. Notice you can always separate fractions when you have a single denominator. It's that fraction minus that fraction.
It's the 74 is the common denominator. Right.
Yeah, I don't know that I would call it a common denominator. It's the principle where you have A plus B over C is, okay, yeah, you're right, because that's A over C plus B over C, and then it is a common denominator.
Yeah.
Now, make sure you don't ever make the mistake that some people tend to make when they know that, and that is that A over B plus C is not equal
not A over B and A over
that
C.
That is bogus.
Yeah.
You have to have a single denominator to be able to split it into multiple fractions.
Yeah, okay.
Okay? All right. What else? What do you got next?
Okay, I'm going to try my best to verbalize this.
Okay.
But this is a find all the zeros problem, and the polynomial, I think, it's x cubed plus 6x squared plus 13x plus 20.
All right.
And then the given factor that we get is x plus 4.
Oh, okay. Well, that's nice. Because, first of all, you probably haven't discovered it yet, but cubics are enormously difficult to find zeros. Okay? And I mean enormously. This might be a 20-minute problem. If you gave me just that function and said find the zeros, probably a 20-minute problem. There is no such thing as a cubic formula like there is a quadratic formula. In other words, you can solve any quadratic fairly quickly by just using the quadratic formula, you know, whether it factors or not.
Okay.
Now, when they give us one factor, the other factor is obviously going to be a quadratic, right? In other words, if we take a linear term times a quadratic, we get a cubic. So once we can figure out what the quadratic is that's remaining, then we can even apply the quadratic formula if we need to, and we'll have all three factors. And we expect three factors from a cubic. Yeah. You cannot have more. You cannot have four factors from a cubic. In other words, the most factors, the most zeros you can have is the degree of polynomial.
Mm-hmm.
So a quadratic has at most 2 zeros, a cubic has at most 3 zeros.
Okay.
Now, how do we find out the quadratic that's going to remain when we incorporate this factor that they were nice enough to give us? That changed the problem into a 5-minute problem.
Mm-hmm.
What do we do with that?
The way that I learned was we would put it into division.
Okay, there's 2 ways to do it. You can do long division, or you can divide synthetically.
Mm-hmm.
You familiar with synthetic division?
No.
Oh, really? Okay. Well, then let's do it long division. And long division is just like any other long division, only there are a few,
More steps.
well, here, let's just go. This is an easy one because there's nothing missing. If we did not have a 13x, we would need a dummy 0 there.
Yeah.
You have to have every degree represented inside the division sign and every degree represented outside.
Mm-hmm.
Now, since we have all of that, this is relatively straightforward. Very first thing you do is divide that into that.
Mm-hmm.
Always
So that'd be
the
x
first step.
squared.
What's that? X squared.
Yeah.
The only thing I care about is dividing x into x cubed. Now I'm going to multiply x squared by both terms.
Mm-hmm.
So I get x cubed. What's the rest of it?
And then it's minus 4x squared.
Plus 4x squared.
Wait, I thought it was the opposite of the sign.
No. With long division, you always multiply this by this. But what you do is subtract at this point.
Yeah, okay.
Okay, so when you subtract this from what's above, what do you get?
You get 2x squared.
Now bring down the next term.
Plus 13x.
And now repeat. Now again, divide that into that.
2x.
Okay, and it's a plus 2x, and you need the plus or minus sign here because this is part of a polynomial.
Yeah.
We can't just ignore the plus because it's plus. Okay, now I got to multiply 2x by both terms. And subtract.
And what? And that's 5x.
Bring down the next term. Repeat. And
Plus.
now,
And we're done.
yeah. Here's a very important concept you haven't learned yet, but nonetheless it's true, and you will learn it. And that is, if x plus 4 truly is a factor of this cubic, then I necessarily must get a remainder of 0. Okay, had I gotten a remainder of 1, then x plus 4 would not be a factor of that cubic.
Yeah.
Okay, so it's called the zero remainder theorem. And when you start dealing in more cubics and quartics, that'll become more important. But just remember that the remainder always has to be 0. If you're doing one of these problems and they've said this is a factor and you divide it and don't get a remainder of 0, that means you made a mistake somewhere.
Yeah, okay.
Because they told us that this was a factor. So it has to be pretty much. Now, what are our 2 factors at this point?
What? So it'd be x plus 4 is a factor. We know that.
What's the other one?
Well, we could break the x, so it's x plus x.
That's the other one right there. Whatever I get as a quotient.
Yeah.
Now, the question is can we factor that further?
Yes, we can.
Well, you always can. In other words, you can always apply the quadratic formula to that. It's just that the answers might be complex.
Yeah.
And they are complex because if I analyze the discriminant, which is what that is, and if it's negative, my factors of that are complex, and it sure is negative. It's 4 minus 4 times 5. So it's a negative discriminant. And now there's a few standards in math here, and one of them is that when you're finding all of the factors of a higher degree polynomial, you get all of the linear factors and irreducible quadratics. That actually is what that is an irreducible quadratic. I can factor it, but it's going to be complex factors. And what they usually do is if you're factoring a very complicated 5th degree polynomial, and you get down and you found, well, I got a factor that's that, I got a factor that's that, I got a factor that's this, and then finally I've got some quadratic that has nothing but imaginary solutions, that's where you stop, typically.
Okay.
In other words, you don't apply the quadratic formula to that. Once you get down, that is called an irreducible quadratic. Even though we can reduce it using imaginary numbers, but if you have to use imaginary numbers to reduce it, it's called irreducible. And I've got multiple precalculus books that say take it down to its linear factors and its irreducible quadratics. Well, in this problem that we're just doing, we've done that. But read the directions again to me.
Well, it's find all the zeros, and if I look at the answer choices, some of them have i's in them.
Okay, well let's fully factor that then.
Okay, so
then what is x if we talk about just that quadratic? Factor it using the quadratic formula. First of all, what's the quadratic formula? General?
A squared plus b. Oh wait, no. What am I talking about? It's b negative b plus minus the square root of b squared minus 4 times ac over 2a.
Okay, now fill it in for this one.
Okay, so it would be. Let me think about this. It would be -2.
This, incidentally, Simon, is pretty much the way every math problem should be started, is with the general formula.
Okay.
If you want to find a way to eliminate mistakes from your work, then start with the general formula, and then you're just plugging in for A, B, and C, and then you're simplifying.
Okay.
Whereas if you try to do both the memory of the quadratic formula and the plugging in the same step, you're just asking for mistakes. Okay?
Yeah, okay.
So, that's why I pretty much tell all my students, my first question on most problems is, give me the general formula. And trust me, your teacher will appreciate it. If your teacher sees problems being done where your first step is the general formula, you're going to get credit for that alone. So what is this? What's minus b?
So it'd be -2 plus or minus the square root of 16, I think.
B squared.
Well, b squared is 4, and then it's minus...
Oh, you were giving me the whole thing.
Oh, yeah.
Okay.
Sorry.
It's okay. I usually like to go through this with people just because there are so many opportunities for mistakes when doing this discriminant here.
Yeah.
You're correct. That's -16. But this is what... You frequently have a negative c. And when there's a negative c, boy, people make mistakes about half the time. So what I tell everybody is do your 4ac as the first step. Then subtract that number from b squared.
Mm-hmm.
Seems like a simple enough thing, but you'd be amazed at how much better that will make your accuracy. So you're right, that is negative 16. And now let's simplify. What's x equal to?
What? So you can, so that would be the
I would do this one step at a time also. Do that first.
Yeah, that's 4i, right?
Uh-huh.
So it's 2 plus minus 4i over 2.
Okay. So that's equal to what?
And then, can you simplify that by pulling?
Divide top and bottom by 2. Again, I've got a fraction, and I can multiply it by the number 1 or divide it by the number 1. So, yeah, I can always divide top and bottom by the same number. So what does that give you?
Well, you divide it by 2, and then that's 1, or negative 1 plus minus 2i over 1.
Just that. Okay. Now, it is important to understand that that means two different answers. One of them is minus 1 plus 2i, and the other is minus 1 minus 2i.
Okay.
What the plus or minus means. And now we've got our other two imaginary zeros. We can now say that these are our factors. Now this is going to look a little strange because you always subtract your 0, right?
Yeah.
I'm going to put inside parentheses there, and there's the plus 2i. And then the third factor is x minus the other one, which is minus 1 minus 2i. And then when you simplify this, you get, in other words, by removing the inside parentheses. So there's your answer. There are your three factors. If I multiplied these three terms together, I would get the starting cubic that you started.
Okay. Yeah.
And that was them giving us one of the solutions.
Yeah.
In other words, if they hadn't have given us this solution, we could have still gotten there to the answer. It would have just been a lot of trial and error and figuring out what that first real factor was.
Yeah.
And it is a lot of trial and error. That's why it takes 20 minutes.
Yeah.
All right.
Okay.
What else you got?
Next problem. This one is kind of like that last one.
Okay.
But we have to algebraically find all the zeros again.
Okay.
And this is x to the 6th plus 3x to the 4th minus 16x squared minus 48.
Minus 48?
Yep. And that's it.
Wow.
Yep, as you were talking about that other thing taking a long time.
No, this is not as hard as it looks. I'm just a little, wow, it's going to be, let's talk about a type of cubic that is not such a long problem. Let's talk about the following cubic. Similar to what we have above, right?
Yeah, kinda.
Now, I just said these are 20-minute problems. Well, not all of them. In other words, there are certain cubics that if the ratio of this coefficient to this coefficient is exactly the same as the ratio to that coefficient over that coefficient, then we can solve them by grouping.
Okay.
Okay? And grouping is a pretty easy method. Here, I'll just go through it really quick on this bottom one, and then I'll show you why it applies to this top formula. On the bottom one, I'm going to put parentheses around the first two terms, and I'm going to put parentheses around the second two terms. But notice when I go to put the parentheses around the second two terms, I've got to change the sign of the 48, otherwise I change the expression. So that's what it looks like at this point. In other words, the secret on these, when you're doing something by grouping or a lot of math problems, is make sure you don't change it. From step 1 to step 2, they got to be identical. And I'm always checking. Every single row, I'm checking. In other words, I'm not going to wait till I'm done with the problem to figure out my mistake. I'm going to check it as I go. Well,
okay.
It's real easy. I can see that number 2 is identical to number 1.
Yeah.
See why I had to change the sign on the 48? Because I put parentheses? Because of that subtraction. If that subtraction sign was an addition sign, then I wouldn't have had to do that. I could have just left the parentheses. I mean, I would have put the parentheses around there, but I would not have had to change the sign of anything. Okay, so now what? Now that I've done that, now factor out the greatest common factor from each set of parentheses.
I think for the first one it's x squared.
Times what?
Times x plus 3.
And the second one?
And then minus, and then parentheses, wait, 8, right? Would 8 be the biggest common factor?
Oh, hold on. My apologies. I wrote this wrong. There's no square there. 16. 16 is the factor.
Yeah.
X plus...
Oh, yeah, of course it is.
Okay. The key is those have to be the same. If they're not the same, you've most likely made a mistake somewhere.
And that's one factor right there.
Or the problem doesn't lend itself to grouping. If the problem truly can be done by grouping, then these two have to be the same. And they can be factored out as a binomial. This is not something you're used to doing. You're used to the greatest common factor being a single term, like 3x squared. How often do you factor something out that is a binomial term, like x plus 3? Well, not very often, but you can do it. What's left behind?
Wait, what do you... Sorry, say that again.
I'm factoring out an x plus 3.
Yeah.
What do I have left over?
X minus 3? I don't...
X squared minus 16.
Oh, and that problem? Oh, okay.
Yeah, I'm doing this problem because it's the beginner slope.
Yeah.
The problem they gave us is the hard slope. I want to make sure you can get through this problem before we tackle the other one.
Yeah, and then you can factor that one out to 4x plus 4x minus 4.
So we figured out all three factors of this cubic.
Yeah.
Without having to resort to anything exotic, okay, other than factoring out a binomial term. Now, how does that apply to this problem? Well,
similar.
It's basically exactly the same. The thing is that there's two ways to kind of look at it. I think the preferable way is to use U-Substitution. I'm going to let U be this term right there. No, excuse me. I'm going to let U be that term. Always. In other words, U is equal to x squared. Okay? Now, what does that mean? That means U squared is equal to x to the fourth, and U cubed is equal to x to the sixth. So I'm going to write this function. Right now, it's a sixth degree function. Well, who knows how to do those? Nobody. But I can turn it into a cubic by using this substitution method over here. What I end up with is u cubed plus 3u squared minus 16u minus 48. Okay?
Yeah, okay, and then you just kind of turned it into
that's exactly the same problem we just did. Identical.
Yeah, okay.
Okay, and what were our factors? Our factors were u plus 3. What was the rest of it? U.
And then u plus 4, u minus 4.
Okay. So that's the way that factors. And now I go back and I resubstitute. So this becomes x squared plus 3. This becomes x squared plus 4. And this becomes x squared minus 4, which becomes x minus 2 times x plus 2. That is an irreducible quadratic, so is that. You can always tell an irreducible quadratic because if this number is always positive, and it is, regardless of whether x is positive or negative, then it is not going to have, I can't factor the sum of squares. Particularly can't factor x squared plus some positive number because that's always above 0, so is that. Okay? So, I've solved the problem because I cannot factor those further. I could factor them using imaginary numbers. And this is plus or minus square root of 3i, and this is plus or minus 2i.
Okay.
Okay? And if you like, I could say that's x minus plus or minus square root of 3. Hold on. Remember, it's x minus the 0, and the 0 was plus or minus square root of 3i. So you get those two factors from that first quadratic. Over here you get x minus plus or minus 2i. Here we have our x minus 2 and our x plus 2. So if they really want you to take it all the way down to complex numbers, you can.
Okay.
And notice we have 6 solutions. There's 2 there, there's 2 there, there's 1 there, and there's 1 there. We have 6 solutions as you would expect a degree 6 polynomial to have.
6.
It's, yeah. Yeah. It's just that 4 of them are imaginary. These 4, let me point with my mouse, I always forget. These 4 here are imaginary. So we have 4 imaginary and 2 real.
2 real. Okay.
But the secret to this problem was realizing that they have not taught us how to do 6th degree polynomials. They've only barely taught us how to do cubics, right? So the moment we see this, x to the 6th, we know we've got to be able to do something really special with it to even be able to do it. Yeah. And there was no greatest common factor. When you first read it to me, I thought you were going to stop at the 16x squared, because at least then I can take out an x squared and I'll be left with a quartic. Yeah. But when you went on and gave me the minus 48, I'm always checking. And whenever I see a hard polynomial, I'm always checking to see whether that ratio is the same as that ratio before you even give me that minus 48. Yeah, okay. Because if it is, then you can solve it by grouping. It makes it a lot easier. Well, it's the only thing you've been taught at this point. Yeah. They're not going to give you a cubic without at least one solution unless you can solve it by grouping. They've probably taught you that because there's no way they would give you this particular problem here had they not taught you how to group. Of course, they wanted to make it an extra hard grouping problem, so they made it a combination of grouping and U-Substitution.
Well,
and this word U-Substitution is used frequently in math. You'll run into it a lot when you get to calculus.
okay.
This is kind of the first place where you kind of get introduced into U-Substitution. And you don't absolutely have to do this part over here. It just makes it easier. In other words, there's nothing in the world that prevents you from going from that step to that step, if you can see it. It's just really hard to do.
Yeah, okay.
Okay? So I would advise always using U-Substitution. And it helps a lot over here. Not only use U-Substitution, but then figure out what U squared and U cubed is. Because you know you're going to end up with a U squared and a U cubed in this function that is now a function of U. As long as these are true over here, then my f of u is equal to my f of x. But the nice thing about f of u is it's a cubic. It's not a sextet, or whatever they call sixth degree polynomials.
Yeah. Well, I got another easy one.
Okay.
Easier one. But it's x to the 4th plus 21x squared. And then minus 100.
Minus 100?
Yeah.
Notice this is what I call a quadratic in disguise. Similar to the previous problem, which was a cubic in disguise.
Yeah.
It was a sixth degree, but it was a sixth degree that I could turn into a cubic without too much trouble. Well, I'm going to turn this into a quadratic without too much trouble. What am I going to let u equal?
Well, yeah, u equals x squared, and then u...
That would make... And then do the rest of it. Figure out what u squared is. That's x to the 4th.
Yeah, to the 4th.
Now I can represent this as a function of u. And it becomes what?
U squared plus 21u minus 100.
Now you can factor that.
Yeah.
What's that factor to?
Well, what multiplies to 100 adds to 21?
No, what multiplies to 100 and subtracts to 21.
Subtracts to 21.
If that sign that's in front of the constant is negative, then the factors have to subtract to 21. Well,
what?
25?
25 and 4, yeah.
Where's the 25 go? With which sign?
Plus 25.
Okay.
Minus 4.
Okay. So we would normally say, well, there's our answer. But you always want to go back and resubstitute. In other words, let's put it back in a function of x. So in place of u, I'm going to say x squared plus 25. And for this one, I'm going to say x squared minus 4, which factors into x minus 2 times x plus 2.
Yeah, okay.
So again, I've taken a 4th degree, a quartic, and I've got 2 linear factors and 1 irreducible quadratic.
And that way...
Again, I know it's irreducible because that's always positive, and I'm adding 25 to it. So,
and that would that irreducible one go x plus 5, or square root of 5i?
Here, let's do it over here on the side. In other words, what I'm doing is solve this equation. Right? So I get x squared equals minus 25, x equals plus or minus the square root of minus 25, that's x equal plus or minus 5i.
Okay.
And so then that's all. If I wanted to write that as a factor, then it's x minus the plus 5i, and x minus the minus 5i, which makes it x plus 5i.
Plus 5i.
And then the other two linear factors that are both real.
Okay, and that's
if I was taking it all the way down, and I should remind you that that's not standard. In other words, your teacher may be asking you to do that, and that's fine. But typically you take it down to what is called an, if this is going to produce complex answers, then you don't need to take it further down. That is an irreducible quadratic. If you have to take it all the way down, then that's the answer there.
Okay.
Suppose you can never get in trouble by taking it all the way down. If you took it down to this step here, he might take off points. Who knows? If he's not under that same assumption that you should only take it down to irreducible quadratics.
Okay.
So by going all the way down to this last step, there's no way anybody can say that's wrong unless they specifically have said take it down to its linear factors and irreducible quadratics, and then that's the right answer.
Yeah.
And they will typically say that. So it just kind of depends on the teacher and the instructions.
Yeah, I think our teacher usually wants us to find all four of those factors, like how with the eyes and everything.
Okay.
So here's another one. It's divide just x squared minus 3x.
Hold on. Is it x squared alone in the numerator or x squared minus 3x?
No, it's x squared minus 3x plus 1.
Okay.
Divided by x to the fourth plus 4x to the third, minus 2x squared plus 8x minus 4.
That's the problem? We have to simplify that expression?
We have to divide, I think, find all the zeros maybe.
No, there's only one way they're giving you a problem like that, and that's if they want you to simplify it.
I think then maybe simplify.
Well, here's the immediate problem. The top doesn't factor, except without using the quadratic formula. And the bottom is a quartic. We have no idea how to factor.
Yeah.
And I can't even use U-Substitution because notice that I can't put this in the form of a cubic or a quadratic because it's got an x cubed term here. Now I do notice one thing, and that is that the ratio of that to that is the same as the ratio of that to that. So I never have heard of grouping on a quartic, but those numbers are not accidentally those ratios.
Well, the way that it's set up on the piece of paper is long division style.
You sure I got the right numerator and the right denominator? Because you can't do this long division style. The very first step is you divide this into x squared and you get 0.
Oh,
and
maybe
the
numerator
is a denominator. Yeah, you
maybe it's
the x squared needs to be over.
Yeah, sorry.
It's the only way it makes any sense at all. Now, notice that I'm not missing any degrees of x. If I were, I'd have to put a 0 of that many x in there. And I'm not missing any degrees of x over here either. Well, I don't need any dummy variables. This is going to play out real simple. Go ahead and work me through it, every step. What goes?
Well, the first one is x squared.
Okay.
And then that would be x squared.
Hold on. You multiply that by each of those three terms.
Yeah. And that would be x squared.
Not x squared, it's x to the fourth.
X to the fourth, I mean, shit.
Okay.
And then minus 3x cubed. And then plus x squared.
Okay, what's the next step?
And then you subtract all of that.
Okay.
And then
These
you
always
get...
go away. In other words, that always goes to 0, or otherwise you've done your division wrong.
Yeah.
Okay.
And then the second one is 7x cubed, right? Because
it's 4x cubed minus a minus 3. So yeah, 7x cubed.
And then would that be plus just x squared?
Minus?
Or, yeah, minus x squared.
1. That's minus 3.
Minus 3x squared, okay.
That's why synthetic division works better for most people, because it turns all of this subtraction into addition.
Yeah, okay.
Okay?
I never learned synthetic, though.
Okay, you will. It'll be coming fast if you're here. Okay, now repeat. In other words, the rest of it is just a repetition of what we've already done. What's the next term?
Plus 7x.
Okay.
And then it would be 7x cubed. And then minus 21x squared. And then plus 7x.
Subtract.
So x cubed is 0. And then that would be minus 24 x squared.
Okay,
oh wait, no.
The tendency is to drop negative signs. Okay?
Yeah.
So the way to do this is always to do it like this.
Mm-hmm.
That way you have not dropped a negative sign, and now you can absolutely do the problem.
Yeah, that would actually be, what, 18x squared, not 24.
Okay. So just always remember, when you have lots of negative signs, don't do it in your head. It's too easy to drop a negative sign. By dropping a negative sign, most people do exactly what you did. They're looking at 3 negative signs, and they're only looking at 2, so they just assume there's only 2.
Yeah.
There's subtraction between those 2.
Yeah.
Okay, what's the rest of it?
And then it's plus 1x, just plus x.
And then bring down the next term.
Yep, minus 4.
Repeat again.
So it'd be 18x, or 18, just 18.
Okay.
And then it would be, well, minus, or plus 18, and then minus, what is,
54.
is that 54, and then plus 18.
Okay. And subtract one more time.
And that's 54x minus...
Hold it. It's 1x minus a minus 54x.
So it's, what, 55x plus, or no, minus 22, right?
No, I've got minus 4 minus 18. That's minus 22. Is that what you said? I apologize.
Yeah. No, yeah, you're good.
I was doing it in my head wrong, I guess. Okay, now if we tried to do one more repetition, we notice that the x squared will no longer go into that first term. That means that's your remainder. In other words, when you get to that step where you can't do that division anymore, that's your remainder. And here's how the remainder looks. It's 55x minus 22. 55x minus 22 divided by your divisor, which is x squared minus 3x plus 1. And this whole thing, since it's a plus, has a plus in front of it.
Yeah, okay.
This is your answer.
Okay.
Exactly like that. And you don't need to put R. You don't need to call that a remainder. And you could say remainder of 55x minus 22, but what a remainder means is the remainder divided by your divisor.
Mm-hmm.
And so this is the exact answer. In other words, if I were to take this trinomial and multiply it by that quadratic and remainder,
Yeah.
I get that quartic.
Okay.
That's always true when you're dividing anything. If I divide A into B and get C, then A times C better be equal to B.
And I think if we go fast, we can do one more.
Okay.
And this is x cubed minus 3x squared plus 25x plus 29. And then there's one factor that is x plus 1.
Notice how hard that would have been to do. I would not have been able to do that by grouping.
Mm-hmm.
And the only other method you haven't learned yet, the 20-minute method. So the way I'm going to do this is, what's my first step?
So I think how I would do this is I would put it into the long division.
Right. Since you haven't learned synthetic yet,
Yeah.
then we're just going to do this by long division. Okay? And we're going to get a quadratic. We may or may not get a remainder. If they said that one of the factors was x plus 1, well,
then we
should get a 0 remainder. If we don't,
okay.
somebody's made a mistake. Okay, so work me through this quickly.
Okay, so the first would be x squared. And then it would be x cubed minus x squared. Or plus x squared. But it would be minus. And then that would be...
Oh, it would be plus. You were correct. It's plus.
Yeah, and then it would be...
You're not putting the minus sign on anything yet.
Yeah, yeah.
You're just multiplying x squared by both of those terms. Then the minus sign goes there. I've got to subtract that whole second expression from the expression above.
Yeah.
Okay, so you don't want to be putting any minus signs in front of individual terms. It wouldn't be correct.
Mm-hmm.
Okay.
But then that would be, well, the 3x cubed would cancel out, and that would be minus 4x squared.
Bring down the next term. Repeat.
And then that would be plus, or no, would it be just minus 4x?
Well, you'll know. In other words, if that's correct, then when I multiply it back together again, I'll get minus 4x squared.
Yeah.
So, do you?
It should...
Well, what's minus 4x times x?
Minus 4x times x is just minus 4x squared.
Okay.
And that should be... wait.
Still have to multiply the minus 4x times the 1.
And that's minus 4x.
Okay, subtract.
Okay, and then that would be the 4x's would cancel out, and then it would be plus 29x. And then plus 29. So then it would just be 29 plus 29.
And that gives you a perfect 0 remainder. And you know that you factored it correctly. Now, that means that our factors are this at this point in time, but we still have a quadratic, and we know that quadratic is not going to factor because why? How can you instantly tell that we're not going to be able to factor?
Is it because...
29 is a prime number.
Yeah, 29 is a prime number.
In other words, we would have to have factors of 29 that add to the number 4. Well, the only factors of 29 are 29 and 1. And so it's not just the fact that it's a prime number. It's the fact that I know I cannot get the minus 4 with a combination of 29 and 1.
Okay.
So you're going to have to apply the quadratic formula on that. Let's go ahead and do it. We got 3 minutes. What's x equal to?
X is, well, if you'd set it up like 4 plus minus the square root, right?
Uh-huh.
Plus minus the square root of 16, because 4 squared is 16, and then minus 4 times 29.
I prefer to spell out every single slot like that.
Yeah, so you don't make
Take
mistakes.
no shortcuts on the quadratic formula.
Okay. And then over just 2.
Right. Okay. Now simplify.
So it'd be negative 80 plus 36. What is that? Negative 116? Or
Looks like negative 100. In other words, 4 times 29 is 126. 4 times 29 is 616.
Yeah, 116. Okay.
So 16 minus 100.
So it'd be,
like I said, I always do those 3 without the minus sign first.
okay.
In other words, do those 3 first, and you get 116.
That's negative.
Minus 116 is minus 100.
So it would be, yeah, minus 100. Yeah, okay, I see.
And that is 10i.
Yep. And then over 2. And you can pull 2 out of all of that to simplify it a little bit.
Okay. So you get 2 plus or minus 5i. And now how do I write that as factors? So I got x plus 1 times what?
So it would be x plus 2
Always
plus 5i, right?
Well, no, again, this can be very confusing, so let's do it the way we know. The factors are always x minus the zeros.
Okay.
These were the 2 zeros. In other words, those were the 2 answers. So the fact, it's just like if we would have been told one of the zeros is minus 1, then that means the factor is x plus 1.
Plus 1, yeah. Okay.
So these are the 2 zeros, then it's x minus the first one.
And then 2 plus 5i. And then it would be x, would it be x minus again?
Minus, yeah, it's always x minus whatever the 0 is.
Okay, and then 2
now
minus.
Pull out your parentheses. In other words, now that you've got those inside parentheses, you're sure that you cannot make a mistake. And when you pull them out, you end up with x plus 1 times x minus 2 minus 5i times x minus 2 plus 5i. There you have it. Multiply those 3 numbers together and you'll get that starting cubic.
Okay.
All right, Simon, I'll talk to you next time.
Thank you for helping me out on this.
Have a good one. Bye-bye.
You too. See ya.